Okay, so this is going to be the second video on solving by taking the square root of both sides. And as a reminder, please feel free to write down questions on the left-hand side that you either can use for studying later or that you're going to ask me in class when you see me. Alright, so if you need to, always flip back to the previous page to remind yourself on the steps that we're using when we're solving these. So the first thing we always want to do, looking at example 5, is to isolate for the variable or isolate for whatever we have inside here. So to do that, we're going to divide both sides by that number in front, which is a 7. So we're going to get 3x plus 2 squared is equal to 4. We're done isolating it, so we're now on to the next step. We're going to square root both sides. Whenever you square root both sides, we're going to end up with plus or minus the square root of whatever this number is. And the square root of 4 is going to be a 2. So now that we have this equation here, we're going to write two separate equations that we're going to solve. So we have 3x plus 2 is equal to the positive 2, and 3x plus 2 is equal to the negative 2. Now we solve them individually. So at this step, for this first equation here on the left, I'm going to subtract the 2. So that's going to give me 3x is equal to 0. The next thing I'm going to do is I'm going to divide by 3. Now because we have a 0 here, we're just going to get 0. 0 divided by 3 is just 0. Now for the next equation, we're going to follow the same process. We're going to subtract the 2. So we're going to get 3x is equal to negative 4. And then we're going to divide by 3 again. So we're going to get x is equal to negative 4 thirds. And kind of ran out of room, but I'm going to try to squeeze this in. We have negative 4 thirds and 0 as our solution set for this equation. And that does say a 3, no matter what anyone tells me. There we go. Okay, so let's take a look at the next example. So again, we're going to solve this equation by using square roots. So we want to isolate for this x squared. So the first thing we're going to do is we're going to get rid of that 22, or subtract that 22. So that's going to give us 2x squared is equal to a negative 18. We're not done yet. We still need to isolate for that x squared. So what we're going to do next is we're going to divide by 2. So now we have x squared is equal to negative 9. Because that x is isolated, or whatever is being squared is isolated, we're ready to take the square root of both sides. So square root both sides. Square root of x squared is just x. Now if you look, we have the square root of negative 9. So kind of the reason why we took the time to actually review how to simplify radicals. Because it's an imaginary number, we're going to have an I. Because 9 is a perfect square, it's going to be a 3. So we're going to have a 3i. And hopefully you're recognizing right now what I haven't written down yet. Anyone? Okay, so remember, you always want plus or minus whenever you take the square root. Now we have two answers here, and usually this is the time when I'm going to write two equations, but we already have an x. But I will take the time to write this as in the squiggly brackets with my set notation, my two separate answers, a negative 3i and a positive 3i. So this is going to be the answer, or my solution set for example 6. Alright, oops, I have two that can pull 6's. That was a mistake. Life happens. Alright, so the next example 6. Follow the same process. I'm going to subtract the 5 from both sides. Anyone who's tempted to add the 5 into 3, shame on you. Not allowed. And let's see, what's 29 minus 5? That's going to be a 24. Good. Okay, so now we're going to still isolate for what we have that's being squared, whatever's in that parentheses. Since there's a 3 in front, we're going to divide by the 3. So we end up with x plus 7 squared is equal to 8. Now we're at the step where we're ready to square root both sides. So square root of the left, square root of the right. And you want to remember, because we have the square root of an x plus 7 squared, they're going to cancel each other out. So all we have left is the x plus 7. I'm going to put this in blue. And remember, whenever you square root both sides, it's always going to be plus or minus the square root of that number. Now 8 isn't a perfect square, so we're going to have to simplify the radical. So this is the time, and I'm going to use a little bit of space on the left, that we're going to make our factor tree and break it down to get it simplified. So 8 is going to be 2 times 4, and the 4 can be broken down into a 2 times 2. So I'm going to rewrite this step. So we still have x plus 7 equal to, it's still plus or minus, but hopefully you guys recognize, because we have that one pair of numbers, we have 1, 2 that comes out of the radical, and then we have this extra 2 over here, so we have the 1, 2 that stays inside the radical. So that's what we get. We're now going to write our 2 separate equations. So we have x plus 7 is equal to a positive 2 radical 2, and we're going to have an x plus 7 is equal to a negative 2 radical 2. Now to solve this, we're going to subtract the 7. So we're going to end up with x is equal to negative 7 plus 2 radical 2. We tend to like having the integer number first, or rational number as the case may be, and this irrational piece to be second. So we like to write the answers this way. Now we're still going to subtract 7, but since I know kind of what we're going to get, I'm just going to write down, oopsies. So we have a negative 7 because we subtracted it, minus, because that's a negative right there, 2 radical 2. And that's going to be our final answers. And now I'm going to put these two guys into the set notation, the squiggly brackets. So we have a negative 7 minus 2 radical 2, and we have a negative 7 plus a 2 radical 2. Okay, let's take a look at the last example. All right, so for the last example, still the same process. We want to isolate for what we have inside the parentheses. So here it is. So to do that, I'm going to add the 19 first. So when I add the 19, I'm going to have a 36. Next step, I want to, oops, I forgot the square. There we go. Next thing we want to do is we want to get rid of the negative 2 in front. So to do that, we're going to divide. So after we divide it, we have 3x minus 9, which we're going to square, and that's going to equal a negative 18. So we're now at the step, we're going to square root both sides. There we go. So the square rooting is going to get rid of the square that we have on the 3x minus 9. So all we're left with is just the 3x minus 9. And you want to remember, whenever you square root both sides, you get a plus or minus. So it'll be plus or minus the negative 18. Now from here, we're going to write our 2 separate equations. So we're going to have 3x minus 9 is equal to a positive, oops, oh, I'm going to totally change my mind. So, sorry about that. Hopefully you guys didn't get too much copy down already. You're probably going to be so mad at me next time. That's okay, I can live with that. Alright, so we have 3x minus 9 equal to, and we want to simplify this negative 18 underneath the radical. We don't want to keep it that way. So I'm going to squeeze that in right over here. So, two numbers that multiply to give us 18 are going to be 6 and 3. We can further break down the 6 to get a 2 and a 3. So if we look at this, we have a pair of 2's. So we're going to have plus or minus 3, because we have that one number with the pair. There's a negative underneath the radical, so I'm going to pull that out. That's going to become an I. The 2 is all by its lonesome, so that's going to stay underneath the radical. Now we're ready to separate this into 2 separate equations. So we're going to have 3x minus 9 equal to 3i radical 2. And then the other equation is going to be 3x minus 9 equal to a negative 3i radical 2. Now to solve this, we're going to add the 9 to both sides. And now we're going to divide by the 3. Now here's the thing. You always want to pay attention to what this actually is happening. if you look at this, we're going to have 9 over 3. Well, 9 over 3 is going to be just a 3. But we're also going to divide this 3i part by 3 as well. The 3 is not going to affect the I. It's not going to affect anything that's underneath the radical. It's just going to impact that number in front. And we can do 3 divided by 3. So that's going to give us a 1i radical 2. And if you decided not to put the 1 there, you're fine. Not a big deal. So let's finish solving the other part. So we're going to add the 9. So we're going to have 3x. I don't like that I just switched colors. I'm going to go back. Erase that. 3x equal to 9 minus 3i radical 2. And again, we're going to divide both sides by the 3 to get the x isolated. So when we do this, again, we're going to divide the 9 by the 3, and you also have to divide the 3i radical 2 by 3. It doesn't affect the I, it doesn't affect the radical 2. We just worry about the 3 over the 3, which is going to give us a 1i and then the radical 2. So now I'm going to put our answer in the squiggly brackets. So we have 3 minus 1i radical 2, and we have 3 plus 1i radical 2. And then we're done. So if you need to, go back and re-watch maybe an example or two. And when you're ready, please complete a summary on what we learned in today's lesson, and make sure you have the summary completed as well as all the notes for next class.